6. Simplifying surds. We've identified why we want to, because we want to be able to give exact answers to things. So how can we simplify this product calculation? What do we do? Neil?
You bring, how do I say this? Okay, so you multiply both numbers inside the radicals.
Okay, so one of the rules for surds, if you remember, is that, well, one thing for me to link to you is surds or radicals are linked with exponents, yeah? So one of the rules that you've used before, that if we have, let's say, AB multiplied together, not added, AB squared, how can you expand that? Is there another way of writing it?
AB, like open bracket, AB, close bracket,
Well, actually, I don't need brackets, do I? It can just be AB
well,
times AB. It's all multiplication. But a better way of writing that would be
A squared, B squared.
A squared, B squared. So we can see that the exponent gets applied to both things. All right? So we've got, because we're linked heavily surds and exponents, we can kind of do the same thing in reverse. So remember, if I have something like x cubed and y cubed, I can go the other way and say, well, that's xy cubed. So with our surds, it makes sort of sense that we can do, well, let's do both of them within, oh, sorry, not plus, multiplied by 5. Okay? Now, do you remember I said this is a topic where, although we're trying to have exact answers, we might still want to use our calculators. Now, if you can't do 26 times 5 in your head, feel free to use a calculator, but I mean, you should be all right with it. What's 26 times 5? Now, is there anything else we can do from that point? Yeah?
I have a question.
Go on, question.
How does the multiplying the two numbers inside apply to the distributing exponent?
How? Because you'll notice that what I've just done there is like doing this one. So the two exponents are separated. So you could treat it like, well, they are in brackets, if you like. So there are the brackets with the surd on the outside.
Right. Oh, right. Okay.
Now, there is another way to put this, which I'm kind of hoping that you do know. Do you know what the exponent equivalent of square root is?
Square. 2.
It's to the power of a half. Do you remember that?
Yeah.
Yes.
So a square root can be expressed as an exponent, actually, as a half.
Right. Okay.
So we could apply all this as exponents.
So like 25 to like the 1/2 power is 5.
Yes. Exactly that.
But the, it would 8 to the 1/3 power be 2.
It would, yes. Well done.
I'm gonna.
Wait, a square can be.
That's your calculator.
Yes.
Oh wait. Oh.
Look, I can show you on my calculator. If I put, I think we were saying 25 raised to the power of a half. Well, I'll just put 0.5, right, to represent my half, equals 5. And as Bella said, 8 to the power of a third, okay, I'm going to have to put my fraction in here, right? 8 to the power of 1/3 is, what do we think? 2. Because a third is like doing the cube root.
That's the one where it's like just a little 3 before it, not a big
Yes. All right. So we can actually, when we're doing our surds, if it gets an issue, we could think of it as, well, what would we do if they are exponents? So that's like this situation now, isn't it? So what do we do? Well, if it was an exponent, we would write it as 26 times 5, all to the power of a half. And that's the equivalent of doing that, yeah? And 26 times 5, we've just said, is 130 to the power of a half. So that's our square root of 130. All right? So that's linking our surd or radical notation with our exponent notation. The same rules apply. So, the next one we'll have a look at, question B, would be if we've got 3 root 21 multiplied by 21 root 5. Anyone want to go for it? Ella?
No idea if we're allowed to do this, but can you times the 3 root 21 by 7? Can you do that?
Well, that would make it 7 times larger, which would change my answer, wouldn't it? Because what you're thinking of doing is when you've got an equal sign and I've got something that's equivalent to, so I can do it as long as it's the other side, yeah? But you can't apply that if I don't have a is equivalent to or an equal sign. So if I do it, I could multiply that by 7, but then I'd have to divide that by 7 to balance it out, yeah? So I can multiply by 7 and divide by 7, fine. But I can't only multiply by 7 unless there's an equal sign, right? Well, Maya had a hand up earlier, actually. I'll come back.
Probably wrong.
That doesn't matter.
Okay,
Gives us something to talk about.
Okay, could you do the 3 times the 21 and make that the outside number and then put in the square root of the 21 times the 5?
That's not wrong then, is it? Because if you think about it, we've got 3 multiplied by root 21. That's what that means, yeah? Multiplied by 21 multiplied by root 5. Now, what's the rule regarding multiplications? Why haven't we got like terms?
Like bases. Just like, if you like.
What
They would be separated by addition.
terms would be separate?
right.
You collect like terms when you've got add another one.
Just simplify. So like not bases.
Yeah, we're not collecting like terms. We are. What we can do though is we can do anything that can be done. So we can do any multiplications. What I was asking about multiplication is the most simple one that you were told when you were little, when you first did it, which was 2 times 3 is the same as
6.
3 times 2.
Oh.
You can do. You're correct though. We can do it in any order. So as long as I don't have any addition or subtraction, I can multiply in any order I like. So what Maya said was true. I can just do 3 times 21. And then I can do root 21 times root 5. So 3 times 21 is 63. And root 21 times root 5 is root 105. So I end up with 63 root 105. Okay? Any issues with that? All right. Right, guys, let's have a look. So we've got 3, what is it, root 5 divided by root 75. Right, so we've got lots of stages that we could write down for this. So what we're going to do, I'm going to break it up into, well, that's 3 times root 5 divided by root 75, yeah? Happy with that? Right, my next stage is to apply what we did before, same with division, same with multiplication. we can then treat it as it's the root of 5 divided by 75. Okay with that? Yeah? I can't respond to a nothing response. Yes, okay. What I can then do is I can simplify the fraction inside the square root. So what is, if I go back up here, what is 5/75 simplified? It's 1/15. I then go back to this form that I had before, and that's 3 lots of root 1 divided by root 15. And Neil, what's root 1? 1 over root 15, which we know how to multiply a fraction by an integer. What we do is we just multiply the numerator. So we end up with 3 divided by root 15. Okay. Now, that does lead us nicely into another thing that we can do. All right? And what we're going to do is this. We are going to rationalize the denominator. Remember doing that? What that means is the denominator of that current fraction is an irrational number. A fraction is just a what? It's what operation? Division. When you want to divide something by something, what's the most important number to have as an easy number? Sorry, bad way of asking, I'm just going to say it. The number that you are dividing by is all important, isn't it? Because what's easy to divide by? 2, 1, 4, 3, all that kind of thing. 0? But if I said to you, I want you to divide by root 2, I have no idea. Yeah? But divide by 2, fine. We can't divide by an irrational number. That's just, but we might be able to divide by a whole number if I can. So rationalizing the denominator is all about writing an equivalent form that does not have an irrational denominator. I don't want to have to divide by an irrational number. So what we can do, how do we get rid of the divide by root 15?
Times root.
Yeah? Square it, okay? But do I square everything?
No.
Yes.
What I do, because I have to make, I need an equivalent form. I don't want to change its value. If I square 3 root 15, I get a different number, right? Yes. But squaring is not, if I square the top and the bottom, it's not the same thing, is it? Squaring 3 and squaring root 15 is not the same thing. All right? When you write equivalent fractions, can you add 3 to the top and the bottom?
Yes.
No. Yeah, you can only multiply or divide the numerator and divide. Yeah? Just to you've seen it, like, what's equivalent to 1/2? 2/4, 3/6. How do I get 2/4? Oh, of course, I add 1 to, no. Doesn't work. I've done the same to top and bottom, doesn't work. All right? But if I multiply by 2, fine. If I square both, no. All right? So I can't square it, but I can multiply it by the same thing. So what could I multiply root 15 by to not make it root 15? Well, we already know. How do I get rid of root 15? I square it, but let's write it in a different way. How do I square root 15? I multiply by root 15. What do I have to do on top? Multiply by root 15. Okay. Now I'm all right. Remember, I am rationalizing the denominator, not the numerator. So now I've got 3 root 15 divided by what? 15. Now I've got 3 divided by 15, which can be simplified to a fifth. So 1 root 15 divided by 5.
So
That's what the book's got.
I see. And either's.
Depends what I'm asking you to do. I would say the convention is we don't leave an irrational denominator. All right? That's not really simplifying, though. I would say once I've got to this stage here, we are simplified, right? So we could argue, well, if Mr. Potts only says simplify, I'm done at that point. But if Mr. Potts says simplify and rationalize the denominator, or just rationalize the denominator, all right, then you know what to do now. Does that make sense? Is that all right? Are we recapping still, or is that new? So when it's saying is, can we simplify, it's saying root 15. Now when we're simplifying radicals, what we're trying to do is reduce the impact of the radical. We want some integer component to it, if possible. All right. Now, which numbers go really well with square roots?
Oh.
Square numbers. Yeah. Square numbers and square roots go together like fish and chips. All right. So the reason why is because a square number can be square rooted. They're the only ones that can. So what we're looking for, right? We're hunting for square numbers or square factors. Hunt for square factors. All right? So when I look at 15, is 15 a square number?
No.
No. So what I can do is I can try and break it up into factors where one of them might be a square number. Now, can I break 15 up into... No. Well, we can break it up into 3 multiplied by 5. Neither of them are square numbers. Now, some people go, I've got it. Well, it's 1 times 15 and 1's a square number. Correct. That's fine, but it doesn't do anything for us. All right? Because root 1 is still just 1 and it doesn't change anything, and I've still got the 15. So this is irrelevant. This is the ones we're looking at, the other factors, and that one doesn't help us. So this one can't be simplified. Okay? What about B? Let's have a look at root 45. Well, automatically I'm going, because I know my times tables, root 45 is 9 times 5. Okay? 9 is a square number. So then I used the rules I did previously, which is say, well, I can rewrite that as root 9 multiplied by root 5 separately. Now, of course, you're all spotting straight away that, root 9 is 3. So we can write it as 3 root 5. Okay? And we're done. So that one has been simplified. So the first one, we would say cannot be simplified, and we leave it as it is and deal with it appropriately. But this one is simplified. And again, that word simplify doesn't mean reducing the number of terms, because we don't have the terms to collect here. It's made it into we've got an integer part. It means we've got less affected by the root. Okay. And then we've got the final one, C, which is root 30. Okay. Is there any way of simplifying root 30? So we're searching for square numbers. We're searching for 4 times something, 9 times something, 16 times something, 25 times, and so on, yeah? So can we get any of those from 30? No? Not at all?
No.
None of these multiply to make 30? No. So we're good. Cannot be simplified. All right. So, a couple of things done and covered. So next lesson you can come in straight. You can do a bit of practice 3 to work on. And now we've got your test. I'll put it on manage back. Your test is next Friday, right?